MAS367/467 and 6003. My name is Kostas Triandafilopoulos. You will have met me one way or another, either from teaching you earlier in the previous years or from the intro week for the MSc. I'm the module leader for those. Wow, that was loud. So I'm the module leader for those modules, and what I'm going to do today is I'm going to talk a little bit about the admin of the module.
Good morning.
Morning. Talk a little bit about the admin of the module, and then we'll start with the content. So these modules, they are dealing with linear and generalized linear models, and I'm going to give you an overview of the content later on. But now I'm going to talk about the structure of the module. So I'm using MOL to teach this module, and you should all be able to access the content in MOL. You should have a link in your MOL page. So the undergraduate versions, the 367, 467, will redirect automatically to the 6003, but the space is for everyone. So the content there uploaded, most of it is for everyone, and where there are differences, I will say so. So for example, for the project of 467. So just to remind you that the people who are doing 367 are going to have an exam in January, a 2-hour exam, and it will be assessed on all that exam, 100%. Those that they are doing 467, still they have the exam, but they have a project as well, and the project counts for 30% of the final mark, and the exam are 70%. And the people who are doing the semester 1 of the 6003 in the MSc, they have an exam in June, which covers, in fact, both semesters, but half of it will be from semester 1. So if you... It's a little bit weird, but okay. So if you look at, if you go to the MOL, and I want also that bit here. So if you go to the web space in MOL, as I said, you will see the link on your MOL page. You will see something like that. So on the main part, here, the white part, you have, so you can click on that here, box, and you will have all. This is a little bit annoying here that it does. You shouldn't do that in your own MOL. So, so there is some information about the module already. I have put a few things. Shouldn't be able to see all of this. Yeah, I don't know how I can switch off that, but you should be able to see a few documents here. I'll go through. So I'll start with the cover page. So the cover page, sorry about that, that's not very good. So I have a better... I'm going to put a PDF which will look at that page. So there are a few documents that will start you off. One is the cover page. This gives you some information about the module. It is your first place of information, together with the syllabus. So I am not going to hand it in like a print form, but it will be there, so you should read that. I'll try to put that. Where's that? How do I look here? Sorry, how do I open it? I haven't used this PC. Let's see that here. So that's you. That should be that one. No. Sorry about that. That's the one here. The local. Right. So hopefully that will be a little better. So that page will give you, I mean, of course it is in MAL, you will have a look, but it gives you some information about the module, things that I more or less already said, 367, 467, 6003, the project for 467, lectures today at 9 and 11 here. In the end of the lecture, a bit after that, maybe in the afternoon, I'm going to post a message in MAL saying what I've covered, and sometimes I'll point out some interesting things. So, for example, what I intend to cover next week, if you want to go ahead and look at the lecture notes, going to come back to this point. The content will be taught through MAL, and here is the same for all three versions, apart from the assessments. The lectures feedback, there will be 3 parts of 3 exercises that will be, we will do them, and I'll provide detailed feedback on those. There will be review questions throughout the module and examples, and some tasks. I'm going to explain those in more detail when I look at the lecture notes. So these 3 pieces of exercises will be the main your main source of feedback. Of course, you can come and see me if you have any questions, or you can ask questions here. This is also feedback, but the formal feedback is given via these 3 exercises based on examples and content in the lecture notes. So you should attempt those, submit those, although they are only aimed at informal feedback. You're not going to get a part of the mark for those, so they're not assessed formally, but there is a strong correlation between the students who attempt those and get feedback and those that they don't. So there is a strong correlation between those that they do the questions and they get the good marks in the exam. Because it forces you to study the material and attempt it, and etc., and get improve based on the feedback you've seen. Of course, solutions will be provided in those exercises and in most of the review exercises and the tasks that you will see. The project for the MAS367, the project will be available in MAL at some time that you will have covered enough material, and yet it will leave you enough time to work on it. The deadline will be the last Friday of the teaching period, week 12, that is. I don't have formal official hours, and the reason being is that there are always classes, people cannot make one date or the other date, so I do not have official hours, office hours, but I'm very happy to see anyone at any time that we are free. Just drop me an email and we'll arrange a meeting. Or you can drop by if I am here and you want to talk to me. I'm happy to see you. Of course, you can also ask questions via MOL in the discussion boards. It is something that we encourage it. The module is offered to part-time distance learning students in the MSc, and these people use MOL and the discussion board as their main source of information, and therefore there will be quite a lot, I hope, going on there. So please ask a question if you like, and you can always post a message as like anonymous. You don't need to reveal your identity if you don't want to. It's not compulsory, of course, but we encourage you doing this. So this gives you a very basic overview of the module, what I plan to do. If you go back to MOL, on here, the drop panel, you have the information, the syllabus of each of the modules. So if you click on 367, for example, that will take you to the syllabus from the University of Sheffield webpage, and you can see the syllabus, the content, and the timetable as well. Oh, you know that if you're here. So make sure that you check, of course, the correct syllabus to the course that you belong to. The discussion boards, just said, they are accessible from there. They just a little bit after below here. So there is a message, a welcome message I have posted. So it's this one. This gives you again an overview of the organization in MOL, and as I said, you should check from time to time the discussion boards to see if there is any interesting information. Usually I will convey there what I say here, but I may forget something, or I may, obviously, if there is like a technical question, I'm going to respond there. I'm not going to repeat everything here in the class. So please do check, even if you don't want to participate by posting a question, or sometimes students are answering queries of other students, which is quite useful. We encourage participation, and of course I will step in if you know, make sure that people are, you know, confirm something or correct something else. If I go back to content, so that should be here. No, that's not it. You have, where is that now? Sorry about that. That's funny. I can access it through here. It's the way that it appears on course materials on this website. You shouldn't have that problem. Right, so no. I said content. I must course materials. Course content. Wrong link. Right, so there are some lecture notes which are here. Click on them. There are almost 120 pages of lecture notes. I'm going to give you print copies of those lecture notes at 11 o'clock. I can show you my copy. That's how they look like. There is a little bit of information here, again, about the course and the lecture notes, and there are 118 pages. Half of it, a little bit more than half, is devoted to linear models, and people should feel quite familiar with a lot of the content on linear models, especially those on the 367, 467. They should find a lot of common ground with the second semester of MAS223 last year. And also people on the MSc, they have reviewed linear models. They've more or less done before, I think, regression, linear models. So hopefully some parts of it, obviously not all, but some parts of it will look familiar. The latter parts, the generalized linear models, it is all new for everybody. Yeah, so the lecture notes at 11 o'clock, you will have copies of this. I'm just doing an overview of what there is here in MOL. We're going to use R for implementing the models in the computer. As you will see in the lecture notes, we have some R commands, and we also have in MOL datasets, the datasets that they are in the nodes. So you are supposed to do yourself the analysis in R, to write the commands and to learn from it, because we are not learning only by just reading and understanding the mathematical concepts, the proofs, all this stuff. You need to understand how R implements, well, not how, but how you can do analysis in R. You don't need to learn the commands or to know why the commands work or how they work, but you need to know what the commands are telling you, what the outputs are, and to be able to interpret the output. Because, for example, in a project or in an exam, I may give you an output of some data sets, and I will ask you to interpret it. So we need to be able to interpret our output, and in my opinion, the best way to do it is by doing the analysis ourselves, not just by reading the lecture notes. So that's why I have here this document, Introduction to R. This document has been around for some time. Perhaps you may see it in other modules, so you may be familiar, but I thought to put it here. It gives you a very, very basic introduction to R. I'm not going to cover any of it here. I will just refer you to it. I would suggest that if you take a glance on it, and of course all of you have seen R, all of you have done R in previous years or in the intro week for the MSc. The MSc students will do a lot more in R in the statistical laboratory, so it shouldn't be like a problem. And in fact, I do think that this document is in the statistical laboratory MOL pages as well. So it should be okay. I don't need to spend time on it. However, if you have questions about the commands, if something is not clear, if you're not sure how to put like the data sets into like the R format to use or whatever, then I'm more than happy to answer questions, and if needed to spend some time here, I can do like a demonstration and provide support this way. So here is the data sets that we will have, the cover page, the lecture notes. Some of these links are not visible to you. Solutions of the past 2 exam papers will be posted at some time. We never do that in the start because there is no point to do it, but the MAS policy is to provide solutions of the past 2 exam papers. This module in this form doesn't have 2 years of running. We used to have a different module 2 years ago, which was only linear models. So we have the mock exam paper we gave last year, and we have the past exam paper of last year's paper. So you will have again 2 past exam papers for training purposes, but this will come in time. I just say it now, it's too early to speak about the exams. We'll have a chance to speak again, but just in case that it is here, I have said it, the exam is an open book exam, and that means that you can bring the lecture notes and any material that is provided to you in here, either in MOL, or I printed off for you, like the lecture notes or solutions of various things, and also your personal notes. All of these you can have with you in the exam. And I say it from now because that means that your focus should not be necessarily, or it should not be at all actually, memorizing formulae. Your focus should be in understanding and be able to do examples and questions, exercises. You will have plenty of these. Here is a space for the exercises. So I'm going to post, so far I see those, you'll see nothing of those because they're all gray shades. Here is the place where I'm going to post the exercises and the solutions. Exercises will come pretty soon, exercises 1. I believe by the weekend I'll be able to post the first set of exercises. The lectures are recorded, and I am going to provide a YouTube link when the first lecture, the first 2 lectures, today's lectures, are available in YouTube. The university has a system, the Encore, which is over here, which records the audio. I'm not going to use this, and you shouldn't need to use this, basically because whatever I'm going to write on the blackboard or on the slides, it will be very difficult to use the audio as a means of revisiting some of the things I've said, etc., etc. And the video is a lot better, of course, because we'll be able to see exactly what I'm doing here. So don't worry about that. The Encore, you can just ignore that. I'll provide the link. It should be available soon. So I'll provide the link and you'll be able to watch the lecture again if you want. Of course, this is not a reason of you not coming to the lectures because there are the videos. It is something to support your teaching experience. Right. So this is more or less the MOL, the overview of MOL. If you know if yourself or you know someone they cannot access the module in MOL, sometimes it happens, has to do with registration or funny things happen in MOL. Please tell them or yourself, drop me an email, and I'll sort it out. I'll include you in MOL. It is very important that you have full access in the module in MOL because so much will be communicated through it. Right. Any questions? Okay. So, to sum up, the lecture notes, we're starting off with us today. Lecture notes, the 2 lectures today, every Thursday. Unfortunately, we don't have today, so have only 1 day, 2 hours, weekly teaching. And 3 exercises for feedback, and loads of questions, review questions with solutions that will be posted separately. So if you take a copy of the lecture notes and you have a look inside, what you will see is that the first 2 chapters, which are dealing, as I said before, with linear models, they don't have any exercises attached. There are some examples, but there are none exercises attached. I am going to post a booklet for these 2 chapters with review, as I call them, review questions. And these are very important because you have a chance to train on examples and to test your understanding to those. Every week I'm going to say which questions you can do, and you should attempt those questions, and you will get the solutions, of course, of those questions. In the remaining chapters, 3, 4, 5, 6, and 7, you have tasks there. Instead of review questions, you have tasks, and again, the task is sometimes asking you confirm this identity, or prove that thing, or do this analysis in R, and I'll try to provide solutions. Last year we didn't have solutions to those tasks. And in fact, here on this page, it says that solutions will not be provided on tasks, but I'm thinking that it will be better if I do. So I intend to provide, in fact, solutions to the tasks, or at least most of the tasks. People find it useful. So if we are happy with all this, we can start with the content, with the lecture notes. As I said, you will have those at 11 o'clock today. If you look at the contents, there are, just mentioned it, 7 chapters. Shouldn't be scared by the number, because some of these chapters are really short, especially towards the end. So the linear models are covered in the first 2 chapters, and that takes you to about page 63, and then the remaining is the generalized linear models. For the linear models, the style is mixed. The style is mixed, formal and informal. I don't think we need that anymore, and I don't want these messages. So, trying to see how we can do that full. Is it full set? Yeah. How can I do that full screen? That's what I'm. So. Slow. Okay, I'll open it with that. Oh no. Okay. Oh, sorry about that. So should be full screen. Yeah, finally. Right, so one important comment that I have here in the beginning of chapter 1 in the lecture notes is that the chapter gives an overview, this chapter in particular, but also the second chapter, they give an overview of linear models, and some proofs are avoided. We will not cover all technical details, because if we wanted to do that, we need the whole module to cover all the technical details. And also because here we do statistics. I am not interested so much to do all the matrix algebra that is involved in linear models or the distribution theory that is required, and it is really the subject of distribution theory, not of linear models. So at the same time, I don't want to have a very superficial kind of treatment that I will only look at our output and I'll be able to interpret the models, but then I don't know what the estimators do, what the models are doing, and all the stuff. So I am following something in between. If there are things that we can easily cover, some proofs, some technical parts, I will do. And some of these things actually appear on the exercises. So we are not going to not do like mathematics or the technical proofs, but I'm not going to do all of them. And there are some things that you're already familiar with, or you have met them elsewhere, and I don't want to repeat myself too much here. So here in this little introductory thing, it tells you that our aims for this chapter is how to present a linear model in matrix notation. It's very important because this is what it allows us to have general treatments of a large number of models, how to fit a model in R, how to do the interpretation, and how to use tests, hypothesis testing, the F-test, etc., etc. We'll see in detail about those things, but the focus is on interpretation, understanding the matrix formulation, some of the technical parts on the estimators, but not all of it, especially not the parts which are tedious. And some of them, they are just matrix algebra or analysis. Well, I like actually matrix algebra a lot, but this is not the topic of this module. And sometimes I will be able to refer to you on some things that we need from there. The same is with distribution theory. I'm not going to cover in detail those things. If you want me, again, to say something more than what it is in the notes and what I am doing here, I'm very happy to hear it, and I can see a way, I can find a way to accommodate it. For example, I can provide some notes in MOL explaining what you want me to do. So we are quite flexible. I want us to be flexible in this module, but here I'm stating what is the plan. Also, before I start, if you look, well, now you cannot look, but you will be able to do that at 11 o'clock. If you look in the end of chapter 1, there is an appendix, and in this appendix I have included some basic facts from matrix algebra and related to statistics. You will see, you have seen all of this in the past, but I just thought to have them there for reference and also for a reminder. Again, if you're not sure for something that it is stated there, then please do ask. I can find an hour or something to do like a revision. If I don't know how I can switch this off. Yeah. Okay. So if we are happy with all this, we can start. So the first section, section 1.1, is introducing the metrics formulation of linear models, and it is supposed to motivate the reader for what it follows. So before that, I have a little bit of an outline here in the slides of what the lecture notes offer. So the first chapter is looking at multiple regression, the properties of the estimators, introducing the estimators, properties of the estimators, confidence intervals, and hypothesis testing. It is basically all the main linear models theory, so only in one chapter. In chapter 2, we have some extra parts of linear models, diagnostics, residual analysis, goodness of fits, transformations, how you can transform your variables in order to the model fits like better, and variable selection. And this is where the linear models end. In chapter 3, we introduce generalized linear models, and it is an introduction to the most general kind of like model setup, but with references to particular simpler models. And we're looking there at models that they do not follow, that the responses do not follow normal distribution. So you can have like discrete discrete observations like from binomial categorical data or Poisson-like responses. So we are using examples to illustrate those models and their treatments, but the treatment is quite general in that chapter, whereas in chapters 4 and 5 we are looking at particular setups and expand on what we discussed in the previous chapter. So you have like categorical data in what is known as logistic regression and Poisson regression. So cases where the response is a binomial distribution or it is a Poisson distribution in the count data. And then we are covering in the remaining chapters, 6 and 7, contingency tables, which are very closely linked to the count data. And of course, some of you have seen contingency tables from the beginning of your statistical higher education in MAS 113 when you did the chi-square test. We'll come back to it towards the end. Yeah. So, going into chapter 1, so the first section is looking at a motivating example and it introducing the model definitions, as I said, matrix form. And then we're going to move on towards estimation using least squares. We are going to use a simple example, simple linear regression, in order to illustrate how you can fit a model, a simple model in R, and how to interpret the outputs. Then we're going to go into the distribution of the estimators, because if you need to construct confidence intervals and to do like hypothesis testing, you need to have the distribution of the estimators. So we're going to spend a little bit of time there, and then maximum likelihood estimation, and finally the model fit and the hypothesis testing after. So sometimes in the slides I have slightly different material than I have in the lecture notes. In some parts it is the same, but with less detail on the slides, of course. But sometimes I have like a different example than in the lecture notes. So this is a case where I motivate multiple regression, and this data set is not in your notes. So we're looking here at, perhaps it's better to look at that. We're interested on this data set on the volume of air expelled in a breathing experiments from several people. So there is like a breathing exercise, breathing out exercise, and you have individuals, 1, 2, 3, 4, 5. The data set is a lot longer, of course, than that, but there is space here only for the first 5 patients for that particular study. We have some variables there. So the variable that we are usually interested in, and the variable that we think that it will be like of interest, it is usually the response variable, and it is the volume here. So the first variable, and then there is a set of other like variables which we're going to call soon as regressor or explanatory variables, because they help us understand how is the variability of the response one, the volume here. So what is going on in that response variable. So here there are various variables which are explained on the next page. So you have the exercise, for example, the second, the third column, the exercise variable. It gives you the it gives you the number of hours exercised per month for every person. Then you have the pulse rate. So it is suggested that the breathing will depend on the pulse rate, and it will depend on how much exercise you do and various other factors. So these are the pulse. The pole is the pollution. So it is the lifetime exposure of that person to air pollution. And then you have some other variables, the 4 variables, which are the asbestos exposure. Again, that is expected to affect breathing, of course. So it's an indicator. We'll call this an indicator variable later on. 1 if it is exposed, 0 if it's not exposed. Smoke, if people are smoking or not. If people had asthma or not. And if the variable home, which here we're looking at different areas in the UK. So 1 stands for England, 2 Scotland, 3 Wales for Northern Ireland. So that gives me an opportunity to talk a little bit about variables in this setup. So the first 4 variables, I will call them as continuous, because it seems that they can take every value in the real line I want them to. I mean, this is actually not very accurate to say, not in a mathematical way, continuous, but in a way that if I think of the volume expelled, for example, it can be any value. Whereas if I think of asbestos, it cannot take other values than 1 and not. You cannot say 1.5, for example. So those variables, the asbestos, home, smoke, and asthma, they are what I may call categorical variables or qualitative variables, because they are taking values which mean something. Those values, they are not just numbers. So 1 is not just the number 1, but it means something. The 3 of them, the asbestos, smoke, and asthma, because they take only 2 values, 0 and 1, they are also called binary variables. So you may call them better binary, not categorical, because there are only 2 categories. The other one, home, is a categorical variable, and we will see in chapter 2 that we'll call this a factor. So this is about the variables. Sometimes the first, the continuous, what I said, continuous ones, they are called as quantitative variables, and the rest as qualitative. Okay. So We will have one variable, in that case, on that example, that was the volume, one variable which is the variable we're interested in, and we're thinking that it depends on some other variables. So this variable is called the response, usually, variable, because it's responding on different values of the other variables. So the response, and we'll have a set of other variables, could be one or could be more, which we'll call with different names. They are known as regressor variables because they take part into regression. They are called as independent variables because they do not depend to each other and to y, to the response. And sometimes they are referred to as explanatory variables, but I explain here some difference between regressor variables and explanatory variables on the next slides. So in the previous one example, the response would be the volume, and all the rest would be the independent or explanatory variables. So we believe that a combination of those can describe the variability of the volume. And hence I have a slide here which describes a little bit some of the questions that we're interested in answering when we do linear models. So before defining anything, then we want to ask some questions. So one question is that which variables best describe the variability on the response? Might be not all of them are needed, might be a combination of those. So which are the best variables that describe the variability? So this is one question. How much of the variation is of the response can be explained from those variables? It might be 80%. It might be 90%. It will not be 100%. You will never have like a perfect fit. So some proportion of the variability of the response is explained from the variables that we believe the response depends upon. So how much? So when we do linear models, there is always some